Alright, in this video I'm going to be working through some multivariable calculus examples, some functions of several variables. We're going to be finding domain and range of these functions, giving a sketch of the graph, looking at some contour maps, things like that. So this is where we are, not really taking partial derivatives yet. We're just looking at these functions, seeing what we can see. Alright, so the first one is find the domain and range of the function. So you can't see that. Alright, find the domain f of x and y equals the square root of 4 minus x squared minus y squared. The same rules still apply that always have applied. We can't take the square root of a negative number, right? Because these functions are we are saying they are going to take in two real numbers and give you a real number back, and we're going to be taking the square root of a negative number and be getting a real number back. So what I'm going to say is for the domain, grab a color here. Domain. Okay, I'm going to need the inside, the radicand, to be greater than or equal to 0. All right, because we can take the square root of 0, but we can't take the square root of a negative number. So I'm going to say that this is equivalent to 4 is greater than or equal to x squared plus y squared. And if you weren't seeing what this was trying to tell you, you could say this is, okay, x squared plus y squared is less than or equal to 4. X squared plus y squared, okay, that's kind of the equation of a circle that's centered at the origin. So it's the set of all circles centered at the origin that have radius less than or equal to 2. So I know that it's the interior of this circle is my domain. And this circle has radius 2. Okay. So I would say that, I might kind of color this in and say that's my domain. Okay, and since this is less than or equal to 4, we are going to be including the boundary, right? If this was less than 4, say it was log of 4 minus x squared minus y squared, then I might draw like a dotted line here to indicate that that was going to be not including the boundary. Okay, so now I'm going to find the range of this thing. And now, okay, if we're taking the positive square root, I know that f is going to need to be greater than or equal to 0. But then I also need to be thinking about, what's the biggest f can be. And since x squared and y squared are both going to be positive numbers for any of these x's, right, any real x's and any real y's, I know that I'm always going to be subtracting from 4. So the least that I would be subtracting would be 0 and 0 right here at the origin. So the greatest that f could be would be the square root of 4, which is going to be 2. Okay, and that's going to be my range. Okay. The second one is arc sine of x plus y. That's nice. Okay, so probably been a while since you thought about that. Arc sine of x plus y. All right, now, thinking about the domain, and going back to, inverse sine of some number t, arc sine of t is going to bring you back an angle that if you take the sine of that angle, you get t. And we know that we take the sine of any angle and we're going to be stuck between -1 and 1. So it doesn't make sense to, say, take the inverse sine of, say, 2 or -3 or something. So we need x plus y to be between -1 and 1. So -1 is less than or equal to, because we can take inverse sine of 1. That's going to pull back pi over 2. Think about the most obvious place on the unit circle where sine is equal to 1. Well, that's pi over 2. And also -1, negative pi over 2. So x plus y, the thing I'm taking arc sine of, needs to be between -1 and 1. But this is like, what does this really mean? If you just need an algebraic specification, I suppose you could settle with that. But I want to be able to draw you a picture like I drew you a picture of the other domain. So what I'm going to do is I'm going to say, well, both of these things are true. This inequality is true and that inequality. So what I'm going to say is that this gives me -1 is less than or equal to x plus y, and x plus y is less than or equal to +1. And then I'm just going to solve for y. So I'm going to go over here, or no, I guess y is going to be greater than or equal to -1 minus x. and y is less than or equal to 1 minus x. Okay, I'm going to draw the domain right here. Okay, and we'll know how to draw the graph of 1 minus x, right? And it's less than or equal to, so I'm going to, have a solid line there. And then negative 1 minus x will be over here. So we've kind of got this, this lane's worth of domain. Okay, this is the domain of f. Right in there. Okay. And then the range, this is kind of just a trivia fact, and it's not super important for multivariable calculus or really for any math course, in my opinion. But if you think about the outputs of inverse sine, it takes in a value of sine and gives you back an angle. And, in pre-calculus, they probably told you that it spits out angles along this part of the unit circle because, all of the possibilities for sine are contained in here. This is also the range for arctangent. Just thought I'd throw that out there. But arctangent can take in any real number because, up near pi over 2 and near negative pi over 2, tangent gets real big or real negative. And so what it's going to be is just f is going to be stuck between pi over 2 or negative pi over 2 and pi over 2. But you would kind of just have to know that fact about arc sine to know that. It's not a huge deal if you didn't. That's why I put it on the homework and not on the quiz. I'll have something more obvious on the quiz. Okay, that's the third one. Okay, now we're going to start sketching some graphs. And this, this is not an art class. This is a multivariable calculus class. And I get that, your sketches may not be the best. My sketches aren't that great either. They have gotten a lot better over time. And so just like anything, if you practice, you're not going to get worse. But the idea is, I think in the long run, what we want you to be able to do is not be able to produce a beautiful sketch, but to be able to just kind of know what some things look like. So if I have g of x and y equals negative 6, okay, that's basically me saying z equals negative 6. And that's going to be a plane. Okay, remember that anything that's linear in x, y, and z is going to give me a plane. So what I'm going to do, I'm going to draw my xy axis. I'm going to draw it pretty laid out, pretty flat. And then I'm not going to need much positive in the z direction. I'm going to need mostly negative. And I'm going to mark off negative 6. I'm going to say it's right there. Okay, and then I'm going to draw a little parallelogram. And let's see. I'm going to need my parallelogram. It's going to need to be parallel to these sides. So I think I'm going to make it so that it doesn't. I should have paused the recording before I made this. I'm going to make it so it isn't like encroaching on other axis lines. Okay, that was supposed to be parallel to the x-axis. It doesn't look that parallel. All right, this is the tough one. I kind of just got to go and do the best I can, and then now I'm going to connect these. All right, and then I'm going to want to block out this part to give me some perspective. So I'm going to use, if you're working in pencil, you might just use your eraser. Me, I'm going to color over this and then say this is now, that's negative 6 on the z-axis. And this is the set of all points where z is equal to negative 6. And if you really wanted to make it fancy, you could, I don't even know if this one still works. I don't really use highlighters very often, but you could, maybe give it some color. And this is, it seems like it's still working. I don't know how it's going to work over my correction tape, and not great. But, you can give it some color. And then it looks a little more like a plane, But, you could always just stick with the black and white version and you'd be just fine. Okay, there we go. And yeah, that looks pretty good on screen, I feel like. That's the plane z equals negative 6. Okay? And those are decent enough to draw. I think we can probably all at least try to draw a parallelogram that's, it's parallel to the x and y axes, for a given z level. I think in linear algebra we drew planes that sat on the other axes too, but those wouldn't be a function of x and y. Okay, so number 4, g of x and y equals y squared. Oh, we talked about this one in class. This one, oof, man. All right. So, first of all, one thing you can do, if it only depends on y, we can give a kind of a front perspective of this and only look at this and kind of draw it in 2 dimensions. So that's what I'm going to show you. And then I'm going to attempt to draw it in 3 dimensions, but man, I'll give you another option too. So option 1, draw, this is z equals y squared. So we know what y equals x squared looks like. So z equals y squared should look like this, right? And what this would be if I had, maybe I'll just draw it like really thick here. That circle here, that's the x-axis. We're looking like directly down the x-axis at the yz plane. And that's going to be the kind of the trace of it in the yz plane. So it's like, it's got this parabola, it's going to have depth, okay? And so in some sense, it's going to be like an infinite taco shell or something like that. It's the best description I can give you for it. Now, if we had to draw this on the XYZ, I'm going to use a pencil. That's the first piece of advice. And also, I know I've got a couple of pretty strong artists in my class this year. And if you've got a better drawing, like if you end up able to draw this better, I would really ask for you to come show me, because I am, like I said, I've gotten better at these sketches over the years, but I'm still not great. So what's happening is going to be, I don't need really any negative z, because it's y squared, it's going to be a positive number. All right, so it's going to depend on y. So really it's like if this is the yz plane in here, it's going to kind of want to go up like that. And this is just going to be kind of a cross section of the surface. And then, well, I guess we would have more of these. Let's see if I can connect them. Now the backside's going to be challenging, I feel like, for me. But maybe I could draw, maybe I'll just do more of these. Just trying to make them all parallel. Because this formula does not depend on x. I don't feel like that was parallel enough, but it's going to be all right. So I'm going to just kind of try to connect all of these. Maybe do a little bit of shading, definitely erasing that z-axis. Now this upper line, this is kind of maybe misleading. I move that back side as well. Maybe a little misleading because it doesn't just stop. It's going to keep going. But if I want to draw you a picture of this paraboloid, well, I'm going to need to, take some liberties. So I'm going to do a little bit of shading here to indicate that this is part of the surface. And then I might, put this a little lower because it's farther away, and artists will tell me if that's reasonable or not. I am going to come back and kind of strongly emphasize the z-axis. I think this one has just gone a little too far. And then maybe I just do this one a little lighter. But then, the y-axis should also be out of sight. Yeah, for sure. You can see that now. And then maybe I'll just more strongly emphasize that on the back. Okay, that's the last one. It is going to keep extending that way, but okay, I feel pretty good about this sketch. I'm going to leave that as it is. Okay, that looks as good as I can get it. Okay. And, realistically, there would be other ones coming up, like, I don't know. Maybe I'm making it worse. Felt like that's as good as I've got. So the next one. G of x and y is 4 minus x squared minus y squared. Okay, I can draw that. That's not going to be nearly as difficult. All right. So I don't even, well, maybe I will put the axes in pencil so I could erase them as I need, because this one is going to have some places where I want to erase axes. All right, so what we're going to do is it's going to be 4, and as x and y get bigger, g is going to decrease. And we know what, say y equals 4 minus x squared looks like, and this is going to look very similar to that, except in 3 dimensions. It's going to have some solidness to it. So I'm going to mark off where I think 4 is. Say it's right there. And then I'm going to say it's like a downward-facing parabola, except it's a solid. And so I'm going to give it some ribs. This is very similar to the example I did in lecture. It was like 5 plus x squared plus y squared. So it's just going to be, kind of upside down from that other one. But we are no longer going to need these things. And, I might actually, let me extend the z-axis a little bit, just to give us some perspective. But I'm probably going to get rid of it up to here. And over here, because, right, this is the surface of the graph, and it's in front of us, or it's in front of the axes. And so now I'm going to draw just like really these are contours, but, kind of like some ribs to make it look like it's got that roundness. And, of course, we want these to be parallel, if two curves can be parallel, which I don't know if that makes sense. I'm not a geometer, really. All right, and then maybe I'll give it some shading. Shading with a mechanical pencil is not always the most fruitful endeavor. And it's going to keep going, obviously, right? X and Y can be whatever they want, and Z will just be always less than 4, okay? Or potentially equal to at the origin, right there. All right, and that's a pretty decent sketch, as good as I've got. All right, G of X and Y equals e to the negative x. Ooh, man. That could be another one like the y squared, but as always, we could start with a front perspective, and then we could go from there. So number 6 is g of x and y equals e to the negative x. Okay, so if I drew z versus x, we know what y equals e to the negative x looks like. It goes through 1. It's got like growth over here, decay over there. All right, and it as x goes towards positive infinity, this thing is going to go towards 0. And I'm going to make a rough draft first before I sketch this for you. Okay, I can draw this. I am going to make x and y pretty long, and I'm going to want y to be pretty laid out here. Not to be pretty flat. And z, I'm going to want quite a bit of z in the positive direction and not a whole lot of z in the negative direction, although maybe I will eventually. Okay, actually I do want quite a bit of z down here. A lot of this is going to get erased, but I'm going to start with this. Okay, then I'm going to actually put in the boundaries of my surface. So maybe I'll just show you, like, if this is x and that's y and that's z. I'm envisioning something that's basically that x versus z coming down here for all the y's. And I don't know if my hand gestures are making sense, but I think that I can draw this. So I'm going to start by drawing the boundary of where I'm going to stop drawing. And it's going to want to be parallel to the y-axis. And so I'm going to start maybe about here and just try to draw something parallel to that y-axis. And that's going to be where we're just going to stop looking. Okay? And then I'm also going to need another one that's up here, also parallel to the y-axis. And this is not parallel enough for my taste. So I'm going to try one more time. But it's not worth, just over and over and over again. I forgot. I've got this thing. Generously provided to me by a student a few years ago after he shattered mine. I mean, in his defense, it did say shatterproof, but just give it that, and then we can always erase. Okay, so that's going to be kind of one boundary, and then I'm going to scoot that up over here. I want it to be, just make it long enough that I can bring in a nice eraser and make that happen. Okay, so what I actually do is I'm going to draw the curve. Okay, I'm going to assume that this is z equals 1 right here. I'm going to draw the curve like that. And then I'm going to keep drawing other curves that are parallel to that until I'm satisfied. Oh, this is horrible. I may just have to show you the one I did on scratch paper. Oh my goodness, this is not going well. Yeah, forget that. Pardon me. Let's look at that. Okay, this is my original drawing. So my plan was, maybe I can cut this off a little sooner and erase a lot. I don't know how my rough draft that did in like 10 seconds ended up better than the one I was really trying on, but maybe there's a lesson to be taken from that. Okay, and then we're going to need to clear out the axes because we can't see them because it's in front, because z is always positive. Okay, I'll let you think about the implications of that, with the perspective and everything. So we go in, do a bunch of erasing. I forgot to get my nice foam eraser out. All right, so here's the y-axis. Oh, one thing I forgot to mention, but I guess I'll just say now as I'm, improving my sketch. There's the z-axis. Is that you can always go to Wolfram Alpha or Google.com and type in 3D Grapher like I do, and I think it takes you to GeoGebra. Or you can, I learned in one of my later afternoon classes this week, that you can just type it into Google, maybe not z, can't remember if it's z equals, but with this one it might be tough. You could say z equals e to the negative x, and then the trick, if it doesn't depend on y, is you say plus y minus y, and it'll give you one that you can rotate, manipulate, and zoom in and zoom out on. But this is as good of a sketch as I'm able to do. Okay, that was kind of difficult. Okay. 6 minus 2x minus 3y. This is something that we are going to be able to graph, because this is going to be a plane, because it's linear in x and y. So let's 6 minus 2x minus 3y. So what I'm going to do is I'm going to write this implicitly so I can find the intercepts. So I'm going to say 2x plus 3y plus z equals 6, and then I'm going to work on the intercepts. So I'm going to say the x-intercept. If you think about the x-intercept, it's going to be where both y and z are 0. So both of these would go away. 2x equals 6, x equals 3. The y-intercept, that would be where x and z are both 0. So 3y would equal 6, giving me y equals 2. And then for the z-intercept, I'm going to have z equals 6. Okay, and so what I'm going to do, I'm going to draw the XYZ space from the front perspective where we're looking at the positive x-axis here, the positive y-axis over there, and the positive z-axis up here. And I don't use this perspective very often, except for really situations like this, where we want to draw a plane whose intercepts are positive numbers. Okay, z equals 6, that's the biggest of all. Which one's 3? X is 3, so that's half as far, and then y is 2, which is going to be relatively closer. And then what we do is, the best drawings of this will have used a pencil and erased this, but that's okay. I've come too far now. And then we're going to connect the dots. This is one of our easier to draw situations. And then, well, I used the really large Sharpie I found on the ground in my classroom one day to fill in the part that's, in front, and then I used pencil to shade in the part that's going down below the XY plane. Okay, but you could just stop at that triangle. That would be a portion of the plane, and definitely a pretty solid graph. So number 8, the last one. Now this one might be tough to draw. I practiced this one time with one of my students, and I know exactly what this thing looks like, but drawing it is a little hard. So g of x and y is half of the square root of x squared plus y squared. All right. If this was z equals the square root of x squared plus y squared, that would be the upper half of the unit sphere. But this 1/2, this is causing problems here. So what I'm going to do is I'm going to say, all right, say this is equal to z. And I'm going to square both sides. Then I'm going to have 1/4 of x squared plus y squared equals z squared. So pretty much what it is it's going to be, it's an ellipsoid. It's going to go, I believe, well, it's definitely a pencil situation. I'm pretty sure I'm going to draw the base of it. This one I might not put axes on. That was what I was thinking kind of after we floundered on drawing it. I think the base is an ellipse. Maybe the base is a circle, but it doesn't, yeah, that's going to be it. I think the base is going to be a circle, and it's not going to go up as high as a sphere should, right? It's not going to have that constant radius thing going on. I think the 1/4 are what's causing the problem. So I'm going to kind of rid myself of the back side of this a little bit and put in a top on it. It needs to be a smoother top than that, but this might just have to do. And we're going to give it some ribs to give it some dimensionality. And okay, yeah, if we think about 1/4 of the square root of x squared plus y squared. Wait a second. Hold on, I'm starting to doubt that. Yeah, the signs are all wrong for this to be part of a sphere. Like, it's not going to have a limited range, right? We can make the square root of x squared plus y squared as large as we want by choosing large enough values of x and y. So really, this is close. I did pull up a 3D image of it on the computer. It's like it's upside down. So I think I just had the wrong idea about it. But this shape, that shape is more or less right. It was just upside down. So what I'm going to do is I'm going to draw, I have a better idea of what this thing looks like now. I'm going to kind of draw it like this. And it is going to have very circular aspects to it because of the x squared plus y squared. You may have noticed that from some of the other things that we've graphed, that if it's got an x squared plus y squared in it, it's going to have some kind of nice circular symmetry to it. And so really what's happening, okay, this is the origin. Okay, where x and y are both 0, z is going to also be 0. And then, okay, ideally this would have been, the same on both sides. But as x and y get bigger, z gets bigger, but not very fast. Okay, so it's going to be, you know, maybe this is negative y. Okay, positive y is not visible, and maybe it's, I don't know what to do. Straight edge is helpful. That's the positive y-axis. Here we should be able to see the whole x-axis based on the perspective we're looking at this from. And then the z-axis, we'll be able to see part of it, but not the whole thing. Okay, we'll definitely see this. We'll definitely see it as it comes out of here. And of course, this, you know, this is extending, right? It's infinite. We just need to have some sort of limitations on it so that we can see. And I guess if it's, you know, it's not actually a solid, it's just a surface, we'll be able to see it go all the way down there, and then we put, you know, a little dotted line or something. And that's going to be the graph. It's pretty decent. Okay, are there any more graphs here? Yeah, no, that's it. All right, now we're going to give a sketch of a contour map, which would be much faster and much more familiar. This will use the skills you have from previous classes, right? We don't really develop the skill of 3D drawing in our math classes up before this. Number 9 is h of x and y is x plus y. Okay, and of at least 4 level curves. So I'll probably do maybe 0, maybe I'll do 5. One where x plus y equals 0, 2 where x plus y is positive, and 2 where x plus y is negative. Okay, so the first, I know that if the domain of this is R2, then my contour map is going to need to live on R2 as well. So just x and y. All right, and so I'm going to start off with the level curve h equals 0. And that will be x plus y equals 0 or y equals negative x. So maybe I will sketch that contour in blue. That's supposed to be going through the origin, and we'll say that that is the contour h is equal to 0. H equals 1, then x plus y equals 1. Yeah, I'll write this one out. And then y equals 1 minus x. Okay, we know how to graph that. We've actually already graphed that line once today. And I'll say it's just right about there. It's going to be y equals 1, x equals 1, okay, parallel otherwise. And then I'm going to say that, and label this one, h is equal to 1. And then, because of the way this, you know, works solving for y, it's going to be the same thing every time. So I'm going to say the level curve h equals c is going to be x plus y equals c, giving you y equals c minus x. So if I wanted to do the level curve h equals, say, 3, I would have to go up to 1, 2, 3, and y. And this is going to be y equals 3 minus x, you know, provided that these are parallel. Okay. So that's h equals 3. And so then you could do a negative value. Maybe I will just do 4 level curves just in the interest of time. And we'll say maybe that's going to be, okay, if that far is 1, then that far should be 2 or something. And I'll just say that that's going to be h equals negative 2. Okay. And there you go. That's a nice contour map for that function. The next contour map we're asked to build is for a sphere. This is actually the equation of a sphere. So 10 h of x and y is equal to the square root of 25 minus x squared minus y squared. And I know that, you know, it wasn't asked for, but I'll tell you, this is a sphere, it's centered at the origin, and it's got radius 5. Okay, so the maximum height of this function is going to be the square root of 25, which happens at the origin. And well, maybe I'll just put this over here. Yeah, that's cool. And I'm going to need quite a bit of color. This is going to be, it's not really a curve, but it is the level set, h equals 5. And then, let's see, okay, yeah, I can do four curves. I was worried that I was going to have to go into the decimal realm, and I didn't really want to do that. So h equals 5 gives us, you know, say 5 equals the square root of 25 minus x squared minus y squared. Square both sides. 25 equals 25 minus x squared minus y squared. And then, you know, I start to cancel this stuff off, and I end up with x squared plus y squared equals 0. And that can only happen when x and y are both equal to 0. Okay, so that's where I get just the point 0, 0. But say h equals, let's say, a little concerned about the, let me think about this. I think 3 and 4 will be good options. Okay, when h equals 3, I'll have 3 equals that square root, and then I'll do the exact same thing. I'll square both sides. So I'll have 9 equals 25 minus x squared minus y squared. Oh, I'll have just enough. Okay, I'm realizing that, yeah, I'm going to do 5, 3, 4, and 0. And that will be perfect. So now I'm going to subtract 9 from 25, and I'll get 16. And that'll equal x squared plus y squared. We know that that's a circle centered at the origin with radius 4. If I had h equals 4, it's going to be 16 equals 25 minus x squared minus y squared, leaving me with x squared plus y squared equals 9. This is a circle with radius 3. And then h equals 0. I'm running out of room, but I think that you'll be able to see what's going to cause h to equal 0. When x squared plus y squared equals 25, it's x squared and y squared. I'm subtracting 25, and I'm taking the square root of 0. So h equals 0 gives x squared plus y squared equals the 25, all 25. So I'm going to start, okay, the first one was centered at the origin. The next one is going to be centered at the origin with radius 3. So let's see, maybe that's here. This is h equals 4. Okay, then 3, then 4, then 5. So I need to just kind of have these be equally spaced with about that much space. So this would be h equals 3, and then 5, 4, 3, 0. And so basically, if I were to put all of the level curves like h equals 2, h equals 1, we would find that the level curves are getting closer and closer together. And, you know, we're not really talking about rates of change yet, but while I'm here sketching these circles, I'm going to let you know that the closer the contour lines are together, the faster the thing is changing. And so I'll have more to say about the relationship between a function and its contour map as we move forward in the course. And so there we go. That's a contour map for h. 11 is h of x and y is equal to x times y. All right. And, okay, draw my axes over here. This one, I'll try to draw it for you, and like I can draw a decent one, but I think it would actually, I'll show you another idea that I've got of a way that you can produce a contour map, and, you know, using technology that I think y'all all have. And so I'm going to just, hold on, start with the level curve h equals 1. And I'm going to graph all the ones that are h is a positive number in blue and then the negative ones in red. I think you'll see why. So for h equals 1, x, y equals 1 gives me y equals 1 over x. I might also say h equals 4 or something. That would be fine. That would be x, y equals 4. Oh, I'll also do h equals 0, because that will also be different. And that will be y equals 4 over x. If h is equal to -1, that'll be y equal, I mean, like, we know how this is going to go. It's going to be y equals -1 over x. And if h was equal to -4, I'll do that. Skipping that, y equals -4 over x. And we kind of know what these curves look like. We have some experience with them. I'm also going to point out, what about h equals 0? Is that going to be possible? Is that going to be impossible? Think about, how could you get h equals 0? And it's like, oh, if x was 0 or if y was 0, h would come back 0. And so I guess I'm going to have to do that one in highlighter. And so I'll just say, x equals 0 and y equals 0, those are the y and x axes respectively, right? So this is the y-axis, whoops, it's supposed to be a highlighter, and that's the x-axis. So maybe I'll just color these in, not with so much highlighter, but this is the level set corresponding to h equals 0. All right. And then y equals 1 over x, we know what that looks like. Actually, I feel like this is a pretty nice contour map. And then 4 over x, maybe that's 4 over x, and 1 over x is going to be underneath it. Because they kind of, they grow towards each other both directions, and it's kind of hard to, oh god, they're not intersecting though. This is a little rough. Then over here, very much the same, except I'm going to start with -1 over x. That's probably too extreme. That's like 1 over x squared, or no, -1 over x squared, I guess. But it's all right. And then oh man, that was a little tough. Okay, alternatively, you bring out TI-84 and start graphing, you know, say 1 over x, 2 over x, -1 over x, -2 over x. And, you know, provided that we're looking at the same window, this is filling out a contour map for us, right? And then, not totally unlike what I drew, you know, close enough. And that's a decent contour map. Okay. Okay, one more. Oh, and then this one, you might be like, ooh, I don't know what that shape looks like. And I don't know what that graph looks like either. H of x and y equals x squared divided by y. I know it's going to have like some asymptotic behavior near, you know, y equals 0, but who knows outside of that. So h of x and y is equal to x squared divided by y. Okay, no idea what the actual surface defined by h looks like, but I can tell you that the contours are going to be easy enough to find. Let's do h equals 0 is going to happen when x equals 0. So that's on the y-axis. I'll do that one. So that's x equals 0. When h equals 1, x squared over y equals 1. That gives me y equals x squared. H equals 2. X squared over y equals 2. So 2y equals x squared, meaning y is 1/2 x squared. Okay. So if I wanted h equals 3, I'd get an even wider parabola, but that's still starting at the origin. So maybe I'll do h equals 1/2, right? And I'll get x squared divided by y equals 1/2. And then when I would multiply, but really cross multiply, I guess, I get y equals 2x squared. Okay. And we know how to draw these parabolas. We've got a lot of experience with that. I'm going to say, all right, the h equals 0, that's going to be the y-axis. And I will color that in here. All right, y equals x squared is h equals 1. Y equals 1/2 x squared is h equals. And so we know how that changes. I don't know if that's quite it, but we know it's wider. And then the level curve h equals 1/2, that's going to come from y equals 2x squared, which we know is going to be steeper. That's a very nice contour map, right? We can do that. And then as we approach here where y equals 0, we're going to get h approaching infinity. Okay, and so there's all sorts of things we could say about that, and that we will say, later on in the course, I think. All right, number 13, last one. Give a sketch of the implicitly defined surface. Okay, I thought I had a list of common implicit surfaces, but I don't know of any besides spheres. I started thinking about it harder, and I was like, I don't know what I was supposed to. I had a note. I was like, hey, put some implicit surfaces in 2.2, but I don't know what that meant. Okay, this is the equation of a sphere. It's going to have radius equal to 3, and it's going to be centered at 0, 0, 4. Yeah, 0, 0, 4. So I'm going to need, let me think about this. I need like some kind of circular object to trace, because I'll just start with this, because I know it's a sphere. I'm going to start with a circle and then draw the axes in around it and give it some depth so that it looks like it's three-dimensional. So hold on real quick. I'm going to go grab something circular from my classroom. Let's see. I think you can see about how well that went. But I don't have very many circular objects in my classroom, which I feel like I should, but couldn't find anything. So I drew a circle, and that's going to be my sphere. The center is going to be along the z-axis at z equals 4. Okay, and it's got a radius of 3, so I know that this is z equals 1, so I know that I'm still above the origin. And so maybe I'll actually use a straight edge to make this look nice. Okay, so maybe it's going to be 1 unit away, and that's going to be the origin. And so if that's the origin, then that means I can kind of freely draw my x and y axes here. So can you see that? Yes. So I can't even draw a straight line right now with a straight edge. So this is the x-axis. Y-axis, we can make that kind of however we want. Say about like that. Yeah, right there. Okay, that's the y-axis. And then this is the z-axis, and I think to that little extra bit, we're going to go right there. And we're going to label that z. You couldn't even see that, but okay, now we're talking. This is a sphere centered at 0, 0, 4 with radius 3, because I'm going to label that as 1. Z equals 1. Now, if you wanted to, you could put in like a dotted line here, and that might be the thing to do, but I'm going to use pencil to make sure this is the right thing to do. I'm going to give this a little bit of that. Maybe I'll even give it a little bit of that. That's not a good idea. I don't know. I'm not going to give it more ribs than that, though. Maybe, should I? Maybe I should. I don't know. How are we looking? Looking pretty all right. And so I guess, if I am showing the back side of those circular cross sections, I should probably also be showing that z-axis. To indicate that that center is on the z-axis. That's as good as I've got. There's a lot of drawing in that. And, you'll be asked next time to draw contour maps for probably something a lot like this. Or maybe like, where was it? That one, right? Worst case scenario, maybe something like that. But we already did that one, so that wouldn't be very exciting. Okay, and that's all I got for you for this video. Thanks for watching.